Turn to our attention to the properties of natural logarithms. As a definition, the natural log of x is the integral from 1 to x of 1 over t dt. A graph of this looks like that. X is 1 here. This is our x value. And the values of this represent the area under the curve from here, from 1 over to x. The domain is from 0 to infinity. The range goes from negative infinity up to positive infinity. The graph is continuous. It's increasing. It's 1 to 1. Its concavity is downward. It spills water. We have 4 laws we want to look at. The natural log of 1 is equal to 0. The natural log of the product is you add the two things together. If you have the natural log of a to the nth power, bring the n out in front, n times the natural log of a, and the natural log of a quotient is subtraction. Let's apply this to 3 examples. Remember that the cube root is the same as raising something to the 1/3 power, so we can use our third law of logarithms here. So this would be equal to 1/3 times the natural log of a minus 1. It's important that you realize you cannot break this up into the natural log of a minus the natural log of 1. Subtraction is only for quotients. As a second example, we take 5, again using our exponent law, times the natural log of. Now because here we have a quotient, we have two things divided, so we're going to subtract. So we take the natural log of the numerator minus the natural log of the denominator. Sometimes we want to work backwards. In this case, we could write this as the log of x to the 3rd power plus the log of y to the 2nd power minus the log of z to the 2nd power. All of these we're using this third law of logarithms, but when we add, that's the same as creating a product. So we multiply these together, and subtraction is the same as a quotient. So this could be simplified thusly.